All right, so this is ME 2611 fluid mechanics. Technically, this is your fluid statics. So, I guess I owe you a recorded session for this, since I only left you ASIC version already in PDF. So this is a pre-recorded session so that it can to help you assist further on understanding fluid statics. Basically, we're gonna talk about pressure heads, then hydrostatic equations. Let's go with our outline. So we're gonna be talking about pressure. What is pressure? Ano yung definition niya? What are the common units na ginagamit? What is yung standard pressure units available na you should memorize, basically, or not exactly, you know them by heart, basically. Ano yung Pascal's laws and then hydraulic machines. We gotta talk about gauge and absolute pressure, followed by hydrostatic equations. Before that, we're gonna be talking about pressure measurements. What is barometer, ang ginagamit yung piezometer and manometer, applications ng manometry, then some problems, hydrostatic forces on submerged planes, and hydrostatic forces on submerged curved surfaces, and then finally is your buoyancy. We're going basic definition half. Okay. And then by the end of this session, I will follow up with there will be 4 samples dito, but I will add them in the next video for some problem sets that I will be solving first, and whatever is left is I'll give it to you guys for you to solve. Okay. For this case, bibigyan ko ng konti lang naman kasi as much as I can is para maging familiarized lang tayo on how to solve fluid static problem. Okay. So we start first with pressure. So if you remember from our last lecture, we discussed properties of fluid and essentially properties of fluids were essentially describing characteristics ng fluid in its system, and pressure is one of those properties where its definition it's called distributed force over an area. I'm not sure if sa class ko sinabi sa inyo, pero with you recall, pressure is normally spread out. It's combined. It's basically applied force, multiple forces siya on a spread area. Okay, and then the more spread out yung area, the lesser the basically force applied, so less pressure. Pero the more concentrated yung area, the greater the pressure kasi concentrated yung force. Pero in this particular case, we idealize it. Lumalabas we represent yung average force na yun over area na yun. So ito yung basic formula. Pressure is equals to force divided by area, where pressure is Newton per meter square. Yung ginagamit SI, or basically Pascals, force newtons, and then surface area in square. So it is a scalar quantity that produces a resultant force by its action on an area. Okay, and then it can also be expressed in terms of liquid height, but we'll get to that. So here are the other pressure units that we would normally be using, or will pop up every now and then. It's a problem. So you should know that for 1 atmosphere, that's also equivalent to 101.325 Pascal, or 101.25 kilopascal. Also equivalent to 1.01325 bar, which is also equal to 760 torr, which is also equal to 760 millimeter mercury. 1 bar is 100 pascals. The additional ones, so we have 1 kilogram force per centimeter squared is also 9.07 Newton per centimeter squared, which is also 9.807 extended for Pascal. Then, if you know the conversion of Pascal and bar, it's a lot easier. For English units, we normally use 1 atmosphere. It's also equivalent to 14.696 psi and 29.8 each mercury. We have an example dito. So if you notice rin, we normally use pressure when we're talking about gases and liquids. Pero when we're talking about solids, we normally call it stress. Tensile stress. All right. So those are 2 distinctions lang. They are of the same unit, basically. But since we're dealing with highly adaptable and flexible matter such as gases and liquid, we use pressure here. We have an example dito, like I said earlier. So the first guy is 150 pounds, standing in an area of his feet around approximately 50 squared. So the exerted pressure against the ground will be around 3 psi. Okay, so you can see your formula dito. It's just weight over yung weight exerted ng body divided by area feet. So that's basically 150 divided by 50. That's 150 pound force divided by 50. That's 3 psi. And you would notice the heavier you are, the greater the pressure. So that would mean the greater the force applied on a limited area, the greater the pressure, just like I said earlier. Just gonna check now if I'm still recording. Yep, still recording. Okay. All right. So next one is, so I guess actually when we're gonna go online, sad. I mean, I was gonna ask if pressure is the same across regardless of altitude. So I drew up a diagram dito. This is visual representation lang that of how pressure relates depending on where you are, on what altitude you are on the surface of the earth to above or whether you're above sea level. So let's define muna atmospheric pressure. So atmospheric pressure essentially is your exerted pressure exerted by the weight of the atmosphere. It's basically it. Just imagine if you have the surface of the earth, and to the edge of the atmosphere, you get a cylindrical component. Then you have column of air that's basically atmospheric pressure. Okay? If the earth were the size of a basketball gun, like the health pillowcase would represent the thickness of the atmosphere, basically. Dito, you would notice that, okay, so however, you would notice your ears popping when traveling to Baguio or cities with higher elevation, or as the airplane ascends to its flying altitude. Climbers requiring oxygen at rests above 7,000 to 8,000 requiring additional oxygen tanks. And it's also the reason why conventional scuba divers can only go at 130 feet below sea level. That's 40 meters. Then basically, we're just saying here that the atmosphere of the Earth is an extremely thin layer of air that extends from the surface of the Earth to the edge of the space. That's basically it. Okay, and the atmosphere here is held in place by our good old-fashioned gravitational force. So just for figure representation's sake, at sea level, our pressure is almost at 101.325 kilopascals. So in this case, London at 35 meters. And you would notice that as you rise, the higher you are, the lower the pressure is, basically, because there's less atmosphere. There's less air, basically. Hence why at airline you have to be in a close pressure vessel that air cabins need to be pressurized. And when you're at Mount Everest at 8,000 meters, you're experiencing 35.6 kPa, and at a certain level beyond base camp, you're gonna require an additional oxygen. And not only that, you're supposed to be physically fit, and your body is adapted to altitudes of lower oxygen levels, meaning you're metabolizing that higher efficient way, which sabi nga daw nila, yung mga Sherpa is highly evolved human beings, because their lungs has 2 times or 3 times the lung capacity na meron tayong ordinary human beings living at sea level now. Then of course, depending on where you are, there are areas around there that are at higher elevations. So sometimes this is very crucial, especially to the northern hemisphere and southern hemisphere when considering design. But for our educational and academic sake, we're mostly gonna be dealing with pressure at sea level, standard pressure and temperature, basically. Okay. And so, speaking about standard, may ibang levels yun. So, we have yung absolute pressure, we have gauge pressure, and then vacuum pressure. Ano ba? It really depends on your frame of reference kung saan mo titingnan. But, say gamitin natin yung, so basically, absolute pressure dito, essentially is the sound. It's the actual pressure at a given position measured relative to absolute vacuum or zero pressure. Essentially, it's atmospheric pressure plus yung gauge pressure depending on where you are. So, yeah. So, yung gauge pressure at a certain height, atmospheric pressure niya, then yung combination, yung sum net totals is yung absolute pressure niya. But sometimes, we have cold bead pressure naman. It's measured relative to the prevailing atmospheric pressure. So, yeah. When you're not considering absolute pressure, so you can eliminate yung atmospheric pressure, we're only talking about yung gauge pressure. Then, of course, we have yung vacuum pressure. Essentially, it's the difference between atmospheric pressure and yung absolute pressure. So, in this case, PV equals to PATM minus PMs. Okay? It's essentially a negative gauge pressure. It's negative because it's giving in. Basically, vacuum pressure mo is gauge pressure nga, but with a negative sign. Okay? Since it's sucking up air instead. Because it has an absence of it's a negative pressure. So, one of the reasons kung bakit you're degassing a pressure vessel and you did release it slowly, sudden release ng gas that would tawag doon. There's a phenomenon, it's like yung para siyang lata ng soft drinks. Kaya kalaki pressure vessel pa yan, will just okay, so remember those formulas. They're gonna be important rin. So just to give an example, so say for example, meron kang gauge pressure na tire at 50 kPa. Usually lalagay ko 50 kPa G kasi para malaman natin ang gauge. And then, meron tayong theoretical atmospheric pressure ng 400. Ano daw yung absolute pressure? Basically, all we have to do lang naman is if absolute pressure lang naman ng tire lang naman yun, be 100 atmospheric pressure plus yung gauge pressure. That's 150. Okay? So let's try solving some problems lang. So for example, here we have a sample problem. Meron tayong air pressure within the bicycle is determined from a gauge. Meron tayong gauge, so that's 70 kPa. 70 kPa G. Yung figure na yun. If the local atmospheric pressure is 104, ano daw yung absolute pressure in the tire? Well, that's easy because we know yung formula. So relative sa surrounding niya, so merong basically 100, meron dito essentially 104 kPa na nakapaligid sa. And then sa loob nito, we dapat the pressure exerted niya gauge is 70 kPa. So all we have to do lang is recall yung absolute pressure is it was the sum ng atmospheric and the gauge pressure natin. So 104, 70. Okay, so that's about 174 kPa. Or, again, doble ko na yung kPa dito. Or, sometimes sinusulat 174 kPa, absolute PBS. Let's try another one. So, meron tayo dito. A vacuum gauge connected to a chamber reads 5.8 PSI. So, we have already a clue na this vacuum gauge, so this gauge pressure should be negative. Now, 5.8 PSI at the location where the atmospheric pressure is 14.5 PSI. We're talking about English data. Determine the absolute pressure in the chamber. Technically, you can follow the same formula pa rin, pero knowing that that's a vacuum gauge, the value should be negative. So that's gotta be atmospheric pressure plus minus 5.8. That'll be 8.7 PSI. This is satisfactory. Lagay mo ng PABs. It's kind of awkward na lagay natin PSI abs. Hindi na lagay na yung partition. Pero normally sa label, that's enough. Okay? So, ito yung mga several examples ng pressure gauges natin, sa mga pressure measurement devices natin. We have yung mercury barometer, we have mga gauge pressures natin. We also have yung piezometer, which is highly accurate. Normally, ito yung ginagamit sa industry. Highly electronic, highly programmable, and efficient in terms of gathering data rin. You see that a lot in instrumentation sa pagdating sa mga gas company, whether depot, refinery, or gas stations. So, na tayo nakikita ko siya sa refinery. Let me just pause for a minute. Okay, session na guys, since technically I wasn't really feeling well for the weekend, it's not the day released recorded video, but anyway, here we are. So essentially, these are the type of pressure gauges that you would normally encounter, whether on the field or sa bahay nyo. Yeah, you normally see this in daily life, like your kitchen. You're measuring your tire pressures at gas stations, or maybe after you work on a machine shop, you air compressors tayo dun, you're filling your scuba gas at oxygen. So the other means of measuring pressure are piezometer and your barometer, which is very interesting. We have 29.98 inch or 76 centimeter, because this is actually an experiment done by Evangelista Torricelli, an Italian, one of I guess you could say student ni Galileo Galilei. He also has a student, si Bertie, pero we'll go into that later. Yung first character natin, sa pagiging importer, si Blaise Pascal, or yung basically yung Pascal's law. Now, knowing from you guys by experience, I could run you the math, or I could just tell you that Pascal's law is basically the intensity of pressure acting at a point in fluid is the same in all directions. I could just tell you that. And this just mathematically prove it lang naman. So, this case, ginamit lang naman yung X and Y axis dito to prove the point na when the applied force, when the applied pressure at point here should be equal on all sides in it. Okay, and this is how they mathematically prove it lang naman. Okay, so pressure is a scalar quantity and not a vector, so it just spreads out really. And essentially saying that the pressure at the point fluid is the same in all directions. Okay? And to prove further yung point, we can use yung hydraulic press, also known as the Brahma press, named after Joseph Brahma, who invented it in 1975. Okay? To demonstrate yung Pascal's law, let's have what we call a hydraulic press. And it's a practical application of Pascal's law natin, since the pressure is equal throughout the fluid. It's basically one of the best use case why we have brake fluids, why such a small pressure, small pihit lang sa brake pedal natin, it exerts a large amount of force agad para enough to, arrest or stop your car. So, say for example, we have a force 1 here, we have force 2 here, okay? So, as you can see here, yung mga arrows idealized, pointed in all directions. It's basically you're exerting the same pressure dito. It's just that the pressure is coming out on different area now. Okay, force is applied on a different area, exerting the same force, and this pressure now goes through another section area, putting out a different force output. So say we apply 100 Newton of force 1 natin. What do you think yung force 2 natin? So we can equate that. So if you call pressure here is F1, basically force divided by area. So we have 100 newtons divided by 1 meter squared. Just for example, so this is 100 pascals. Okay, it's easy. But per Pascal's law, the pressure being experienced here should be the same and transferred across here then. So we can equate the equation just like so. So basically, this is force 2 divided by area 2. Area 2 natin is 2 meters squared. So isolating yung equations natin, isolating force 2, that will give you 100 pascals or Newton per meter squared times 2 meters squared will give you 200 newtons. So essentially, force then can be transferred across a fluid, gaining what we call mechanical advantage. Okay, it's very efficient. Ito lang in-apply mong force and then dinoble siya kasi iba lang yung cross-section. Okay? So, another additional information lang dito, just in case tanongin kasi nakita ko sa board exam before. Mechanical advantage essentially is output force divided by input force. And using our sample, so pag tinanong ka sa problem, ano ba yung mechanical advantage after mo ma-solve to? So what's the mechanical advantage of this hydraulic press? All you have to do lang is output force, yung kunin mo lang yung ratio ng output per input. And you will get 2. And you would explain that our hydraulic press provides a 2-to-1 mechanical advantage. Just getting yung ratio lang naman. Okay? Siguro something much more familiar na example. For example, pneumatic jack is used in a service station as shown in this figure. So if the car and the lift weigh about, so this one, the entire system here, so we can idealize them as 25 kilonewtons. They weigh about 25 kilonewtons. So you target your force downward dito. Determine the force that must be developed by the air compressor at P, so at point dito, to raise the lift at a constant velocity. Air is in line from B to A, so there's air dito. Okay, and has an inner diameter of 15 millimeters, and then the post at the A has a diameter of 280 millimeters. So, ano daw ang kailangan na force that the air compressor must be developed in order to raise it constant velocity? Okay, so now that we know our nodes, so we have to find and know our ask. So we have to find yung force at compressor. Pwede naman sabihin natin FP na lang. What do we have ba? We know that the car lift is 25 kilonewtons. We know that the diameter at point A is 280. That's 8 meters. We know that the diameter at point B is 15 millimeters. At least from my point of view, hindi siya period. So that's 0.015. Wait, how about? So 15 millimeters. Yep, 0.015. Just checking now. And then what's next? Having said about air, so we neglect its weight. Okay lang yan. So the solution, recall that, pressure is force over area. And muna tayo sa, normally, you can actually do an FPD if you want. Okay? Pero in our case, pwede natin yung diretso. So we start with point A muna. And you'll notice, we have 25,000 kilonewtons yun. So that's 25,000. And we already know yung area, so we have a diameter. And that's essentially by, pwede mo yung diretso pi over 4.8 squared. Or in this case, ginawa ko na dinivide ko na lang yung diameter to para okay rin. Pi r squared. So that's about 406 times 10 to the third power pascals. A lot. And then by pascals though, yung pressure A ko dapat dito should be equal dito sa should be the one being exerted the PB. Okay, so and then from there we can use that to solve yung amount of force na kailangan natin na kailangan i-release ng air compressor. Okay, so kailangan ma-develop air compressor. Isolating yung formula and just getting you product na nakuha nating pressure times yung area at point B, which is 0.015. May ginawa pi over 4, 0.015 squared. It's okay, it's the same thing naman. Cancel yung meter squared, so we will get 71.747. So just imagine that you only need 71.7 newtons to generate such to lift 25,000 kilonewtons. Okay, just checking now if I'm still recording. You good? If you have any further questions sa akin, you can send me a PM, or since magkikita naman tayo next week, I have my consultation hours na feel free to drop by if you want to have your papers by the way. Okay? Especially in quiz. Also, I need to talk to the people who not have the quiz, let me know what your excuse is. Okay? So next up is naman yung hydrostatic equations. Ito na tayo. Much more practical. So in this case, hydrostatic equations, we might idealize a lot of variables, including yung fluid mechanics, including yung treating our liquid as a compressible, which would make our density constant. Although we have equations for varying density, we will stick with solving pressure problems with constant density, lalo na when we're dealing with water. Okay, so with hydrostatic equations, basic equations we solve to solve pressure problems, in which fluid is in a hydrostatic equilibrium. When you mentioned hydrostatic equilibrium, just like yung statics before, a fluid is in equilibrium when a fluid is stationary or at rest. The acceleration zero, and with only forces involved that can balance the weight of fluid are the pressure force and the viscous force. Okay. There are two conditions, and like nabanggit ko kanina, we're only gonna be dealing with constant density hydrostatic algebraic equation. Okay? So you would see here, essentially lang naman, you can represent yung, if you recall yung P absolute pressure natin equals atmospheric pressure times gauge, can also be represented in terms of height and here's what we call pressure head. Basically, pressure head. When we're talking about pressure heads, basically we're talking about gauge pressures, and ito yung solution. So that's H is P over gamma, or gamma is density times basically that's rho times G, acceleration due to gravity. And remember, acceleration due to gravity natin we'll be using is 9.8066, especially during exams. Okay? So you can represent gamma H into rho GH. So basically this is P amps, this is atmospheric, and this is your pH. Okay? And pressure can be expressed in head from meters or pressure for pascals. Okay? So makikita nyo dito, iba yung pressure at this level, then iba rin yung exertion at this level dito, at P2, where P2 is greater than P1 because mas malalim yung. Okay, kung makikita nyo dito, iba yung distribution ng forces niya, especially along if we are in a pressure vessel rin. And later we'll deal with that later. Okay, you have to take note ng several concepts. So just like I said earlier, pressures differ when they have different depths. Right? So for example, P1 and P2 are not equal because there are different depths. Meaning iba yung pressure nararamdaman. Pressure head at P2 is far greater in P1. Also, that same pressure due to different fluid strengths. Even if they are the same pressure, P2, even if they're the same points, pero if they have tawag dito, I know this is possible since oil will definitely flow better for this example sake lang naman. They will differ because they have different fluid density. And the other part is because for P1 and P2 here, even at an uneven surface, even at different configuration, as long as the same depth, same fluid, they experience the same fluid, P1 equals pressure 1 should be equal to P2 because they have the same depth and they're operating in the same fluid. Just through this parang rock. Okay? So, here's an example of a barometer. Here's a water column and then the mercury barometer. Okay? And Bertie's and Torricelli's work basically laid yung foundation for understanding yung atmospheric pressure and the principles ng barometer. Okay? So, ang kwento nito is that, for example, for Torricelli, like I said earlier, is one of the students in Galileo. Experiment began by, with a long glass tube. This is just a representation na lang. And sealed at one end, filled with mercury. Ikot ni Torricelli yung open end of the tube upside down and submerge it in a container containing mercury. So ito siya. And then, as he did this, ang napansin niya, in-expect niya actually kakalat yung mercury and tatapon. Pero it just maintained at a certain level lagi. And And I'm guessing meron siyang measurement dito bilang ito 0 and then pero to, at a certain height, laging 0.76 meters. 0.76 meters. But it, did not fall to 0 as one might expect, but instead settled at a height about 0.76 meters or 760 millimeter above the level of mercury of the container. So, itong measurement na to is commonly referred as yung atmosphere natin, or yung 760 millimeter of mercury. Okay, and it's equivalent to average atmospheric pressure at sea level. Now, yan na rin naman ginawa ni Bertie with a glass tube filled with water, pero in this case, ginawa niya rin yun. The water level inside the tube would settle at a height representing the atmospheric pressure. In this case, lumalabas na, depending on anong elevation niya, minsan 11, minsan 12, pero naging constant yung 10.32 meters sa kanya. Okay? And Bertie's experiment demonstrated that the weight of the air above the water column exerted pressure on the water supporting it to a certain height. So, two separate occasions, they tested it on different liquid strength. Basically, the experiment proved that may pumipigil na puwersa or pressure kaya hindi nagsispill over yung liquid. And if we're gonna represent it in a parang FPD diagram, so ito yung ponong liquid natin. In this case, sabihin natin either, you can apply naman either mercury or water. You will realize that there is an atmospheric pressure dun. In fact, you can actually compute for it if you know yung densities. So, for water, that's 1,000. For mercury, that's 13,545 kilograms per meter cube. All you have to do na lang is basically multiply your density times 9.8066 yan. So 1,000 times 9.866 times 10.32 and see ano yung magiging sagot. It'll be almost closer to yung absolute pressure natin, yung atmospheric pressure natin of 101.85. Not exactly. Ganon rin with mercury, so yung 13,545 times acceleration due to gravity. Ginagamit ko kasi 9.866. And then times 0.76. And you would realize almost closer to 101 kilopascal. Pascal yata, sorry. Yeah, so just divided by 1,000 Pascal. Okay? So that's how your barometer works. So let's have some sample problems now naman. So for example here, what is the water pressure at a depth of 35 feet actual? Tide dito. Trick question lang, may elevation 200 to 50. So all we have to do lang naman here is 0.1 and 0.2. 0.1 here is atmospheric, basically. 0.2 dito is gamma 2 H2. Essentially, since this is English, no? So 62.4 pound force feet cubed times 35. Just so happen I know yung the specific weight of water. So that's about 15.167 psi. So what is the water pressure at the level of 35? Ilang na reading natin. If tinatanong ko the absolute pressure at that point too, all you have to do is just add yung atmospheric pressure natin. Now 14.696. You get 99.86 psi. Oh, wait a minute. I convert this now. .4 35, then of course you just convert and I'll be able to be a side of it. You 1 divided 2. Well, just so for here naman, oil with specific gravity of 0.8 forms a layer at 0.9 meters. And an open tank that is otherwise filled with water. Okay. I guess that's supposed to be feet squared. Wait lang. Diba we get over 64.4 times 35 times 1 over 44 essentially. Yeah, man, ako. So that's 15.1666 or 167 PSI. See the importance of unit cancellation. Kailangan may feet dito. Cancel yan. Square. Dito down dito. Sinarkat ko na lang. Basically, you have yung 1 over 12 square. Basically, feet squared to each squared. Yung cancel yan. And then you will have the 1.67. Okay, now with the next problem naman. So, oil with a specific gravity. Yes, nag-decide yung Capify ko na magkaroon. Ganun. So, we have an oil with a specific gravity of 0.8 forms a layer of 0.9 meters deep in an open tank that is otherwise filled with water at 10 degrees. And then the total depth of water and oil is 3 meters. And ang tanong dito is, what is the gauge pressure at the bottom of the tank? So we're talking about gauge pressure. Pero nakapatong kasi is, there are two fluids na nakapatong sa atin. So basically, you just have to add up lang all the gauge pressure that to determine yung pinaka-gauge pressure sa pinaka. Okay? So we have some givens dito. Water at 10 degrees is specific weight of 9,810 Newton per meter cube, and we have a specific weight of oil, which is at 7,850 Newton per meter cube. So that's given. So I think what I did dito is I just played around with the formula. I know I can get yung at yung gauge pressure at 0.2. Alam ko na oil. All I have to do lang is basically is P oil is gamma oil times H oil. So that's 7. Convert ko ito into kilonewton. So that's 7.85 kilonewton meter cube times 0.9 meters. So that's 7.065 kilopascal. Then alam ko ito, since this is with water, essentially P3 here is technically the gauge of oil plus the water. So the P water here is yung specific weight of water times height of water. Okay, so that's about 20.6 kilopascals. So ginawa ko 9.8 meter cube times 2.1 meters. So that's 20.6. So all I have to do na lang is just add them. So that's 27.67 kilopascal. Sir, tanong nyo, bakit yung sinabi yung point? Well, if we're gonna talk about yung gauge na naman dito, hindi na siya gauge kasi atmospheric na yan. A gauge pressure mo atmospheric is 0. Relative sa reference point na yun. Kung mapapansin mo, habang paangat ka, at oil dito is 7.065 lang. And then sa baba dito, the water, 0.2. That's 20.6. So all you have to do is just add them together. Now, if you're being asked kung yung absolute pressure at point, all you have to do is just add all the pressures, known pressures together, including yung 101.325 to get your P3. Then you have your 128.995 kilopascal. Okay, and dito naman tayo, and kalamitan ginagamit natin is manometer. Measure yung pressures natin. And manometry here is very important kasi it's a field of science that deals with evaluation of pressure of fluid. Manometer yung device na ginagamit to measuring yung pressure by raising or lowering volume. And often in the shade of U. Yeah. Now, if you're worried, normally hindi na natin iniisip yung capillary guys kasi the diameter of the tube should be large enough to ensure that surface tension effect and thus the capillary rise is negligible. R should be greater than 3 mm. So, I have two cases dito. So, I'll use one ito. So, essentially, if you want to determine your gauge pressure at 4, you can start at this opening or pwede rin at this point. So, from here, we're talking about gauge pressure now. So, gauge pressure at 1 is 0. But at point 2, you have a change of height dito. So that's gamma, whatever this device, in this case, ym, gamma m times delta h. And with the usage, since same level yung point 3 and point 2, so basically, pressure ng point 2 is equal to point 3 via Pascal's law. And then from here, P3 is also gamma times L, negative gamma, times yung length niya dito kasi it's basically opposite. Okay? And then from there, P4 is just simply P1 plus P2 minus P3. Okay? And then P4 here is 0 times plus gamma M times delta H minus gamma times L. That's how you get yung gauge pressure though. Put it simply, dadaanan natin ulit. So here's another example. So halimbawa may atmospheric type pressure dito. We have fluid with height 1, we have fluid 2 with height 2, and fluid 3 with height 3. We know na we can get yung pressures neto by getting yung gamma and H. So by multiplying gamma and H. So P1 here is equals to gamma times H, P2 here is gamma 2 times H, and P3 here is gamma 3 times H3. So paano natin makukuha yung pressure at U? We can do it step by step. To solve, select a reference point. So in this case, pwede tayo from the top. So gawin natin, pababa tayo. So we go, pababa tayo all the way down. From the top down. So i-add muna natin atmospheric pressure plus yung P1 plus P2 plus P3. Yun yung magiging pressure ng PU. Pwede rin naman from the bottom. Mangyari nun PU minus P3 minus P2 minus P1 equals to P3. And basically, transpose pa ng sa kapila. It's kind of funny way of putting it that way. Okay? I prefer yung top. Top to bottom. Okay? It's just negative kasi direction yun is against it lang. And since here we're going along with the positive direction, so it's easier that way. So PU here should be yung opposite pressure exerting yung all three fluids above. So just to generalize yung formula sa manometry, so for example, meron tayo dito, another example, okay. So we have an air dito, we have oil, H1, H2, H3. Okay, what we do is we start at the point or end or entrance. Pwede tayo dito or dito. Okay, so we start at the gauge pressure. Pwede natin gawin yun. So PPG tayo dito. Plus yung gamma 1 H1, so that will be a oil. Same direction pa rin. Gamma 2 H2, so pababa pa rin, positive. And then pag paangat na, negative na yan. Okay, although same yung pressure at point 1 and point 2, mangyayari dito at point 3 natin, gamma 3, H3 is negative na. Then equals to atmospheric pressure. Okay? Yung switch ng positive and negative side, mangyayari din sa we're from going down up. So when we're starting at gauge pressure. Pero when we start at the open naman sa baliktad. So ito naman yung positive. So we know na atmospheric pressure plus gamma 3 H3 minus so from here na gamma 2 H2 minus gamma 1 H1, that will be equal to gauge pressure. Okay? So yeah, add the different pressures, check the sign, positive when going down, negative when going up. Okay, gano'n lang naman yan. As long as nag-crossover na tayo from going down to up, okay, change the tayo na sign. Hence, very important kung saan magagaling yung reference point. Okay, then equate the formula with the endpoint. I know it's a lot to take in, pero it's best to absorb it one by one and go back through the notes. Talino naman siya. But it's best to understand yung concept by applying it in the problem. Say we have a manometer dito. This manometer is used to measure the pressure of a gas in a tank. The fluid used has a specific gravity na 0.85. Okay? And then the manometer column height is at 55 centimeters. So yung difference, the opening dito at this point, 0.2 and 3 dito. Pati ako na nag-label nito. Is 55 centimeters. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within that. Okay? So what is the The local atmospheric pressure is 96. Determine the absolute pressure within the gas. So, absolute. Okay? So, really, kailangan natin involve si atmospheric pressure dito. So, paano natin gagawin? Kailangan natin si PABS, given tayo ng atmospheric pressure 96. Meron tayong height ng column ng liquid dito is 5 centimeters and meron tayong specific gravity ng fluid at 0.85. Okay, so define dito 0.1, 0.2, 0.3. That's basically yung 3 points mo nun, including absolute pressure dito. So, recall natin yung recall that the absolute pressure is equals to the atmospheric pressure plus gauge pressure, which is equal to rho times acceleration due to gravity times height, or essentially gamma times height. Okay? So, we can substitute na kagad yung mga values na kasi una sa lahat, we have din mga values dito eh. So, we have 96 kilopascal. Remember na magkaroon ng unit cancellation. So, just sinargat ko lang. Let's put it down actually. Let's put it here. KPA. Natin dito, may KPA ako dyan. So, basically, they're squared. And then, plus the product of the 1,000 times specific. So, kasi ginamit ko yung specific weight. So, para makuha ko yung density. So, that's basically 0.85. Para makuha natin yung density nila ng liquid. So, yung 1,000 kg per meter cube is yung water natin. Times 9.806 para makuha yung specific weight. And then, times yung height na to, which is at 155 centimeters. We will get an absolute pressure of 100.6 kilopascal. Now, if we're gonna get yung yung gauge pressure lang naman, all we have to do is just minus lang yung known atmospheric natin, and we'll get 4.6 kilopascal gauge. Hindi siya hinahanap, pero just in case tinanong. Okay? And here naman, we have another one. So we have a funnel here, figure 2-21. It's filled with oil. I think this is a Himmler naman. Makita nyo yung example ko sa Himmler. Okay? And it's filled with oil and water to the level shown, with portion CD of the tube containing mercury. Okay, so may mercury in between dito. Okay, so determine the distance H the mercury is level from the top of the oil. So, kailangan natin malaman yung height na to. And we're given densities. So we have density ng oil is 880 kg per meter cube, density ng water 1,000. And then density ng mercury at 13,550 kg per cube. Okay, and we're given yung mga dimensions. So we're here to find yung H. Then we have our given. And ang solution natin, since fluid is liquid, so we will treat this as incompressible. So pwede natin gawin, we'll pick a reference point muna. So in this case, we pick from A, and we're gonna go through D. A to D via manometry. Okay? So how do we do that? So gagawin natin, kailangan natin malaman yung PA plus PB plus PC minus PD kasi babaliktad na siya dito eh. Diba? That will be equal to 0. Okay, pwede natin tapon yung PD sa kabila actually. In this case, yung gauge pressure natin dito, we can treat this as a gauge. So walang gauge pressure walang gauge pressure walang gauge pressure si point A, so 0 yan. Pero meron tayong pressure at point B, which is density ng oil times acceleration due to gravity times height AB, so that's 0.3. Ito naman, this is BC dapat, hindi yan AC. We just correct that. There we go. Why? Okay, and then from here, so that's density of water times yung acceleration due to gravity times yung height nito, so that's 4 minus yung pressure at T, so that's mercury, so that's 13,550 kg times acceleration times yung height difference basically. So kailangan natin mahanap yung H dito, so HAB plus HPC minus yung H. Okay, so basically ito lang naman yun. Okay? So rearrange the equation to find H. Wait a minute. It's not exactly H equals to 0. Yeah. H. So equate natin ganyan. Magiging HAB plus HBC minus yung tone fraction. And we can now substitute. Okay. So may mapapansin mo, magsisilabasan yung G's. Cancel out 0.3, 0.4. That's about meters yan. And we have 880 kilogram per meter cube times yung 0.3 meters, 1,000 meters squared yan. Okay. So lahat sila may kilogram per meter squared. Ito magka-cancel ang kilogram dito. Conventional unit natin would be meters. So this will be equal to 0.651. And do not forget yung units. So this is 0.651 meters or 65 centimeters. Okay. I think I have another problem dito. So ito naman, determine the difference in pressure between the center line points A and B, and in two pipelines in figure 2-22. Now, if the manometer liquid CD is at the level shown, the density of the liquid AC dV is at density ng 800 kg per meter cube. CD is density ng CD is 1,100 kg per meter cube. So parang water, oil, water, that thing, you know? Okay. Okay. So determine the... So, wala natin makita yung difference in pressure. So we need to find yung pressure difference, or basically P delta PAB. PAB is PA minus PB lang naman. And ito yung given natin. So we have density ng AC. The density in AC and DV is essentially 800 kilograms. So AC, B is 800. And then CD between here is 1,000. Okay, and then we have his respective heights. I think in-identify ko na. So each AC ko dito is 0.03. So yun yung difference out of the. And HCD, C and D dito, that's 0.065. Difference sila. And then DB here, that will be 250. So that's 0.25. Okay? We have to see lang yung difference na. If you're going from B to A, that's a lot different rin. But technically, gano'n rin. So yung solution na apply natin yung manometry will dito. So we go from B to A. Let's check lang natin. So for PB, so pangat tayo dito, that's minus dB. Pressure ng PDB. So that's density ng dB, that is G, that's HBD. And then bababa, so that's positive. So density ng CD times G times HCD. So okay, so far so good. And then we have like P pataas, pababa, and then pababa. So that's positive AC times G HAC equals to PA. Yeah. So we can replace ito. May natin dito PB or yung PA minus BB. So pinaliktad ko lang naman yun, equals to negative dB times G HBD, tapos density ng CD G HCD plus density AC G AC. So substituting yung mga values ito, in-equate ko lang sa labas yung G, so yung 9.8266. Kaya ako sila mag-compute. So ang lalabas ito, kilogram per meter squared, meters per second dito. So magiging difference ito is negative 1,024.79 or basically negative 1.035 kPa, which only means one thing. Mas malaki yung pressure ng PB kesa kay pressure A. medyo mahaba na siya ng konti. Pero yung bulk ng work mo dito is yung analysis ng problems mo dito. Height, ano yung pipili ka ng frame of reference and understanding yung cancellation ng units. Do not do what I did. So essentially here, pwede mo siyang hilatag, okay? Para malinis ka. Okay? So here's different kinds of variations ng manometers. Kung paano yung configuration nila. Pwede rin natin angle. Okay? I'll show that in a future video sa problem sets namin. Okay? And that ends yung part 1 ng video na to. So yung sunod na part 2 ng video na to will be fluid statics naman. So that you can absorb it as smooth as possible.